This is the second video on the graphs of trigonometric functions. In the last video you have seen the graph of sine function and cosine function. In this video we shall see the graph of remaining functions. Okay, the first one here is graph of tan function. You know the values of tan 0, it is 0, tan 30 degree is 1 by root 3, tan 45 degrees is 1, then tan 60 degrees is root 3, and then tan 90 degree we say it is infinity, and root 3 if I say it is greater than 1. And you know y is equal to tan x is the ratio of opposite side to adjacent side. Okay, so in a right angled triangle. So in a right angled triangle, if this is my reference angle, this is the opposite side and this is adjacent side. Sometimes opposite side may be more than the adjacent side, and some other times adjacent side may be more than the opposite side. So tan x value may be less than 1 or greater than 1. So it includes all the real numbers. Okay, any angle can have values more than 1 or less than 1. Why I refer this? Because for sin x and cos x you told, okay, that value always lies between -1 to 1. Okay, with this let me start plotting the graph of y is equal to tan x. Y is equal to tan x graph. Angle is plotted along the x-axis 0 degree, 30, 45 degree, 60 degree, 90 degree, 120 degree, 120 plus 90 plus 45, 90 plus 60, 90 plus 90, 180 like that. Okay, then 210 like that. And as per the values along the y-axis is concerned, this range can have, range is the set of any real numbers. Okay, but domain if I say, at 90 degree it becomes infinity, and at every odd multiples of 90 degree, 2n plus 1 we say, odd multiple of 90 degree means pi by 2, 3 pi by 2, 5 pi by 2, at all those values tan 90, tan of 3 pi by 2, tan of 5 pi by 2 becomes infinity. Okay, so with this introduction I plot the values. So along the y-axis, as I am plotting the values, it is 1, 2, 3, so on up to infinity like that. But for my reference angle 30, it is 1 by root 3 means it is somewhere here, little less than 1. And then tan 60 is root 3. Root 3 means it is greater than 1. So I have plotted this root 3 above 1. Okay, and then here I get 2, 3, 4, so on like that. Similarly, along the negative y-axis we have -1 by root 3, -1, minus root 3 like that. Okay, now tan 0 it is 0, tan 30 degree it is 1 by root 3, tan 45 it is 1, tan 60 root 3, tan 90 it becomes infinity. So the curve goes like this, and here we cannot assign the value means it is parallel to the y-axis. The line is parallel to the y-axis we say. Then when the angle is negative, tan of -30 it is -1 by root 3, tan of -45 -1, tan of -60 minus root 3, tan of -90 is infinity. It goes like this. Okay, after that 120 is there. Tan of 120 means what? Tan of 90 plus 30. 90 plus means cot 30. Cot 30 it is minus root 3 like that. The value comes here. Like that tan 180 becomes 0, and here somewhere it is 270. So at 270 it becomes infinity, and at tan 180 it cuts and then it goes like this. And at 90 it becomes at -90 it becomes infinity means it goes like this. Okay, so this is more clear in this graph. Tan 0 is 0, tan 45 it is 1, tan 90 it goes infinity. Okay, like this. Then tan 180 becomes 0, tan 270 it is infinity means the values, the graph comes like this. Tan 90 becomes infinity, and then after that tan 180 becomes 0, the line comes like this. Okay, you can refer this graph. So it is the graph for tan function. Here as per the domain is concerned, I say any real angle I can consider except odd multiples of 90 degree. Okay, odd multiples of 90 degree. And as per the range is concerned, I can assign any real number for all the remaining angles except odd multiples of 90 degree. 90 degree agirbodu, 270 agirbodu. Allella tan 90 becomes infinity. Tan becomes infinity. Similarly, I can plot the graph for cosec x. You know cosec 0, it becomes infinity. But cosec 90 degree, it is 0. So when I plot the points, cosec 0, it becomes infinity. We can't assign any value for this. But cosec 90, it is sin 90 is 1, no? Sorry, cosec 90 it is 1. Cosec 90, it is 1. Okay. After that, for pi, cosec of 180, if I take cosec of 180 plus 0, so at 180 it becomes infinity. The line, we cannot assign any value here, so I will draw a line which is parallel to the y-axis. Whenever a line is parallel to the y-axis, its slope is infinity, we say. Okay. So we have the discontinuous graph like this for cosec x. Similarly for sec, you know cos 0 is 1 means sec 0 is also 1. Sec 0 degree is 1. But sec 90 degree if I take, you know cos 90 is 0. Its reciprocal sec 90 means it becomes infinity. So at 90 degree I can't assign any value. So I will draw a line which is parallel to y-axis. But for all the angles less than 90 degree, I can assign the values. At the end we get sec 0, it is 1. And then if it exceeds 90 degree, I have this. So we have a discontinuous graph like this for sec x. Similarly, just the reverse of this tan will be the image for cot, because tan 0 is 0 means cot 0 becomes infinity here. Cot 0. At this point, we draw a line which is parallel to y-axis. After that, any angle less than more than 0 degree, I can assign the values till I get cot 90 as 0. Here tan 90 is infinity means cot 90 becomes 0, because 1 by infinity will be 0. Thus, we have these many graphs for the given trigonometric functions. Okay, practice these graphs. In the next video, we shall start the compound angles. Thank you.